Hi, Mauricio.
Hi, Anand. Very nice to see you again.
Likewise. Very nice to see you too. So, today my guest is Mauricio Resende. He's a principal research scientist at Amazon Seattle. Mauricio has a very long career with many publications as well as with many key contributions to the field of OR. For example, he's a co-author of the GRASP matrix, which is very famous. Uh, he's also a co-author of the first efficient implementation of the Karmarkar's algorithm, just to name a few of his contributions. He's part of the advisory board of many well-known journals. He collaborated with many important figures such as David Johnson, Fred Glover, Narendra Karmarkar, and so on. The impact of his publications is very, very impressive. He has, according to Google Scholar, more than 27,000 citations. So, Mauricio, I don't know how to thank you for accepting the invitation, and I'm truly honored to have you here. Muito obrigado. How are you?
So it's also an honor here to be interviewed by you, and I'm very happy to be able to share with everyone uh, what has happened to me in my lifetime, I guess, because we're going to start way back when I was still very young.
Exactly. You were born in Maceió, but you grew up in
Yes,
Rio, right?
yeah, that's right, that's right. My mother originally is from Maceió, which is a city in the northeast of Brazil, and she married my dad in 1954, and they got married in Rio, and they lived in Rio. And when she was expecting me, she and I was going to be the first child. She decided that it might be a good idea to go back to Maceió to be near her family there, and that's why I was born in Maceió. And then about a month after I was born, we moved back to Rio.
Okay. Maceió is actually not that far from João Pessoa.
Yes,
So yeah, so you are technically a nordestino, right?
that's right.
You
That's
were
right.
born in the northeast region of Brazil, but you moved to the U.S. at a very young age, correct?
Yeah. So what happened is that we lived in Rio for a few years, and then in 1958 we moved to a university town about 50 kilometers from Rio, where the rural University of Rio was located. My dad was hired as a faculty member there, where he taught organic chemistry. And at that time, for you to be a professor, you didn't have to have a graduate degree. So basically, my dad was a chemist. He had completed his undergraduate in 1954, and then we. So he was there working for a couple of years, and he decided that he wanted to get a graduate degree, and he applied initially for to go study a master's in food science, which was what he was working on back at the university, and we moved to the U.S. In 1962 when he started his Master of Science program at Purdue University in West Lafayette, Indiana. And so we lived there for about 11 months while he did his master's, and then he decided to continue with his studies in the PhD, and he was accepted to a doctoral program at University of Massachusetts in Amherst, where then in 1963 he started his PhD. So we lived in Amherst between 1963 and 1966, and so that was between my ages of 8 and 11. And basically, when I went to the U.S., I didn't speak any English, but I remember that when I was in Amherst, so a year after I arrived, I was already fluent in English. So at that age, it's very easy to learn a new foreign language. And so we were there my dad was there studying, and in Brazil in 1964 there was a military coup, and the military took over. And at that time, they requested, I don't know if it was all, but a large number of the Brazilian students abroad to come back to Brazil. And so my dad would have to interrupt his PhD and return to university. And he didn't want to do that. And he said he wouldn't. And eventually he was fired from the university, and he lost his position there. And so he stayed at Amherst until 1966, when he graduated. And finally he was hired by Standard Brands, which in Brazil own the Fleischmann Royal brand, and he moved to Brazil to work there. And so he moved there. We lived in Rio, and since we had learned English, my two brothers and myself, he didn't want us to lose the English that we learned during our stay in the U.S. And so we were enrolled in the American school in Rio, Escola Americana. And I ended up studying there for 7 years. My two brothers did their whole primary schooling there. And so he worked for this company for about a year, and then he switched to another company, another American company, which was Coca-Cola. And so my dad was director of R&D for Coca-Cola in South America, and so he had very close connection with Atlanta. He would go often to Atlanta, and later on that would have some influence in how my career turned out because of that.
Wow.
But yeah. Yeah.
You lived about 4 years in the U.S., right?
Yeah, that's right. 4 years.
Mm-hmm. You came back, joined the American School of Rio, and how did you choose your undergraduate course?
Yeah. So first of all, my father was sort of a role model for me, in the sense that he did his PhD. So I had this in my mind that I would be doing a PhD sometime in the future. And so the choices, I decided that I was going to do my undergraduate in Brazil, and more specifically in Rio. And so I prepared, after I finished the American school. American school uses the American schedule, so the year there ends in June, and so then from June all the way to the January, when the entrance exams take place, I didn't have school. So I enrolled in a preparatory course, which was called Curso Vector course in Copacabana, and there I prepared for the exam, and then I chose the university. There were basically two main universities there: the Federal University of Rio, and then the Catholic University of Rio. Those are the two top universities, and one of them was very close to where I lived, which was the Catholic University, and that's more or less how I chose. So I could take a car and then drive there in maybe 10 minutes. So it was very, very handy.
Yeah, you chose the nearest neighbor criteria for picking up the university.
That's right. And curious is, I didn't really know what I wanted to study, except that it had to do something with math or engineering. And so after lots of thinking, you had to decide in your major to take the exam, and I decided on doing civil engineering. And so then I passed the exam, and I started the civil engineering course in 1974. At that time, the first 2 years you do a basic cycle, so you do, your calculus, your physics, and your linear algebra, introduction to computer science. So the this introduction to computer science I did in the first semester, and I just fell in love with programming and computer languages and things, and this had a big impact on my decision of career, and so I decided right after the first semester that I wanted to change departments. At that time, if you wanted to study computer science, there was no undergraduate program in computer science, only master's and PhD in Brazil. So basically, people would do electrical engineering and with a focus in systems engineering. And so I applied to transfer, and I was accepted, and then I started the electrical engineering program.
Right.
And
so how was the experience of coding in those days?
yeah, first of all, coding was done with cards, punch cards. And you had this big typewriter that you'd stick the card in, and would program line by line. Each line was a card, and then you'd get the deck of cards, and you'd give it to someone who would then read those cards, and they would run the program. And then there was a bin system where your output would go to this bin, and then there you'd go and check the output and say, compilation error. So then you have to go back and change that card and redo everything. So it's a very long process and very slow.
Yeah, I can imagine.
And, yeah.
Right. Did you have any OR course at PUC-Rio?
Yeah. So since I did systems engineering, basically, you do the regular electrical engineering stuff, but then you'd also do things related to computer science, programming languages, operating systems, data structures, and so on. And then you'd also do things related to control theory, like state space theory and several mechanisms and things like that. And then you'd also do things related to operations research, both optimization and probability. So we'd had stochastic processes. So I had my first linear programming course. We had 2 linear programming courses as an undergrad, and that was I think in the 3rd year, because I finished the whole thing in 4.5 years. The program was a 5-year program, but I finished in 4.5. So in the last semester, I did very few courses because I was also doing an internship back then.
Mm-hmm.
And also in the last semester, I was doing my undergraduate thesis, which was also an operations research project. It was a system to optimize transportation of oil subproducts on multimodal. So it would be basically trucks and trains. And so we had to model this, and we'd run it on MPSX, which was a solver that ran on that big IBM machines, and we did all this with cards. So we had a box of cards, which was the program, and then we had 4 boxes of cards, which were the data, and then you'd bring everything, run the program, then run the boxes to read the data.
Yeah, and the cards, they must be organized in a certain order, right?
Yeah, and that's a problem, that if the thing falls.
Yeah.
So the way we did the programming was in Fortran. So Fortran had the first 72 columns were dedicated to the program, to the instruction, and then the last 8 columns, because the card had 80 columns, the last 8 columns was for numbering the cards. So in case something fell down, you could sort the cards in some order. And then,
right.
Yeah. The other curious thing that happened back then was that Rio de Janeiro is a very humid city, and the PUC, the university, is right inside of a forest. And so the humidity would get to the cards, and the cards would actually get a little bit thick with the humidity, And then when you ran it into the card reader, it gets stuck, and then you'd have to buy new cards and actually copy the cards from one. So periodically we had to regenerate cards so we could keep on using it. And I say we because at the time this thesis was done in a joint with Abilio Lucena,
Wow.
who studied with me, and it was a joint thesis, and we worked together. And so I've known Abilio since then, and we're still pretty good friends.
That's amazing. That's amazing that you got to study with Professor Abilio Lucena. He's very
Yes.
well known here. And we are talking about 1978 or something, 1977?
Yeah, so I graduated from PUC in 1978 in June, because I did it as I said, 4.5 years. And so at that time, I wanted to go on to my master's, and I had applied to several universities, and the best one that I was accepted to was Stanford,
Wow.
which was like the big place to go,
Yeah.
because that's where Danzig was, and I like linear programming very much. And it was very expensive, though. We didn't have scholarship to go there. So my dad, being a Coca-Cola executive, would go often to Atlanta, and then on one of these trips, he told his colleagues there that I was going to go to California. And they said, no, you shouldn't go to California. You should come here to Atlanta, to Georgia Tech. And I had never heard of Georgia Tech, but they actually took him there to talk to the head of the department, and they explained to him how the department was organized and everything. And he was pretty impressed. And he sent me some literature and also an application form. And they actually sent it in the Coca-Cola pouch mail. So I received the thing maybe on a Tuesday, and then I did Wednesday to fill out the application. And then on Thursday, I put it back in the pouch mail and went back to Atlanta. Back then, there was no fax or anything, express mail or FedEx or anything like that. So companies they had their own pouch mail. And basically, I was accepted there. And the cost at Georgia Tech was about a fourth of the cost at Stanford. So then in September of 1978, I started my master's there. And master's was there was no you had an option of either doing a thesis, or you could take the PhD qualifying exam in lieu of the thesis. And I decided for the latter. And so I basically took 16 courses in 4 quarters, 4 courses each quarter, and then I took the exam, and I passed the exam. So with that, I was able to get the degree. And the exam was actually it was at the end of the 3rd quarter. And so what happened to celebrate passing the exam, I had a vacation in California, and then I fell in love with California, and I said, no, this is where I'm going to come to do my PhD, not in Atlanta. And so I had that in mind when I went back to Brazil. And so I went back in August or September, I guess, early September of 1979, and then I joined the same company and the same group. It's called the Models and the Methods and Models department of Furnas, which is a large power company in Brazil. And they did basically OR applied to electrical power systems. So it's a very nice place to work, and it's a very high level place. And I got hired there and worked there for 3 years. So from 79 to 82. And at that time, my girlfriend, Lucia Polverelli, was also an undergraduate student at PUC, also in electrical engineering systems, and she liked operations research. And so we were basically waiting for her to finish her undergrad so that we could move to the US. and so we got married in '81, 1 year before we moved to the U.S. And then I applied to Berkeley and to Stanford. That's where I wanted to go. I applied to some other places too, Georgia Tech, of course. And I got into to Berkeley. And I said, so this is where I'm going. And so we moved to Berkeley in August of 1982. And I've been in the U.S. since then. So it's been a very long stretch.
Mm-hmm.
And at that time, Lucia didn't speak English, and so she could read a bit of technical English because at school they had to read books in English, but she was not fluent. At least she didn't think she was fluent. And so the first year she wanted to do a master's, and so the first year she decided to just learn English. So she did English as a second language. And very quickly, she had enough English to pass the TOEFL. So I think in 3 months, it was enough for her to pass the TOEFL to get into Berkeley. And she took one of these linear programming courses from the PhD program as an extension student. And that was with David Gale was the professor. And she had a chat with him saying that she was sorry that she couldn't speak English very well. And he says, "I know, compared to some other students who are here, you speak fine." So that was pretty good. And so she also applied to Stanford and to Berkeley for the master's, and she got into Stanford immediately. And Berkeley took a little while until finally she said she was going to go to Stanford, and then Berkeley accepted her. And so then she was going to start her master's, but we had a problem because she didn't have a fellowship, and we'd have to pay for the tuition. So we went back to Brazil, and back then there was a lot of inflation in Brazil, and also the amount of money you could take out of the country was very controlled. So basically, you could take each person could take $2,000. But what happened is that the $2,000 that you buy that in the bank, the official exchange rate. But if you go to a travel agency, they would buy those. If you had $1,000 to sell to exchange, they would buy it at a rate that they usually give to tourists, and that was much higher than the official rate. So we had this. Each one could buy $2,000, and then we could sell those $2,000 to the travel agency and get Brazilian money, and then you could pay for education abroad in the official rate. So then we submitted the money, we sent the money, wired the money, the official rate, and we were able to pay for her master's, starting with very little money. So that was
right. This is a very nice workaround. You found a solution.
Yeah.
So before we talk about your period at Berkeley, you mentioned that you spent 3 years in working at Furnas, and I think you mentioned once that you coded a homemade simplex, and you did some pretty cool things there. Can you comment a little bit about it?
Yeah. So this group that we worked in, it was quite interesting because even when I went the first time to join as an intern, the guy who was the head was a guy with the last name of Camozato, and he sat down with me. He says, our research areas are this and this and this, and it was like he was treating it as though we had a research center there. So when I joined as a full-time employee, I actually got to do some research there, and my manager was Rui Campelo. He was very nice to me and let me work more or less on whatever I wanted to there. And then I was very interested in implementation of operations research algorithms because I had done some work at Georgia Tech with Leon McGinnis, and I got interested in that. And so I was interested in simplex method, and I actually implemented a simplex method that we used then for one of our applications at Furnas. Yeah. And the interesting thing is that when I was an intern at Furnas, we were still programming using cards. And when I came back as a full-time employee, they had just upgraded to terminals. So then we had maybe 4 terminals for the whole team. So you had to do some time sharing on the terminals.
Take turns, right?
But it was a big improvement.
Definitely.
It was the only thing that was bad was for my eyesight, because working with terminals, I started wearing glasses.
Oh,
Yeah, that's when I started wearing glasses.
right. So back to Berkeley. Can you tell me how was the experience there? What
Yeah.
research you did, and so on?
Yeah, so in Berkeley, the department there was very competitive. The students were all very good, and first year is quite stressful because you have to take an exam that's called the prelim exam, which basically covers linear programming, nonlinear programming, stochastic processes, and then you can choose some other topics like network flows and reliability, for example. And you take these exams over two days, and you have to pass this exam to continue the PhD. And the first time I took it, I didn't pass, and so then you actually have, if you're sort of borderline, they would give you another chance. So in 6 months, I took it again, and then I made sure that I passed. But that was sort of stressful, and but fun. Then once I passed that, I started I did a lot of courses, because there you do like 3 years of coursework before you do your thesis, right? So those 3 years, I at the end, sort of towards the end of the 3 years, I started doing some research, and my research was basically in 2 areas. One area was what ended up being my PhD thesis research, which was in scheduling of the operations of semiconductor manufacturing. At the time, the state of California was pushing for research in that area because they had a big semiconductor industry, and so they were funding a lot of projects in electrical engineering, and it turned out that one of the areas that they wanted to fund was scheduling, and so my professor Roger Glassy was able to offer a research assistantship to work on that project. And I saw that, I said, okay, I'll take it. It looks to be an interesting problem. And then I worked on that and that ended up being my PhD thesis. But at the same time, I got very interested in something else, which was Karmarkar's algorithm. So Karmarkar in 1983 published a technical report after he just joined AT&T Bell Labs, where he described a new algorithm for linear programming, and in this paper, it was just basically a theoretical paper. But in the year that followed the publication of this paper, between the year that he published this tech report and then he published the paper at a conference in 1994, and also the Combinatorica paper, which was also in 1984, he gave several talks where he made claims that his method was 100 times faster than the simplex method. And that got us very interested in this. Especially, we had Elon Adler, who was our professor for linear programming there, and he was a former student of Danzig at Stanford. So Elon was very interested, and basically we were going to do a fixed point class that he had, a course, and then he said, no, instead of that, let's read Karmarkar's tech report. And so we spent the whole semester reading the tech report so we could learn about Karmarkar algorithm. I actually implemented a version of his algorithm using the programming language called APL. I don't know if you're familiar with that. It's a language that IBM put out that has primitives for operating matrices, and so you could implement the this algorithm very, very easily.
Mm-hmm.
So it could do like the solving the direction finding system. It's just one line of code. You can only solve toy problems, right? But it was interesting. You could at least experiment with the algorithm, see if it converges and this and that. And so we studied this algorithm, and then I remember that in December of 1984, I made a trip back to Brazil for vacation, and during this, when people found out that I had been studying this algorithm, they invited me to give a talk at CEPEL, which is the Center for Research Center for Electrical Power Systems in Rio. And I believe that was the first talk on interior point methods given in Brazil. So
Awesome.
that was we talked mainly about the algorithm, and that in fact it was an algorithm, and you couldn't implement it. It had a lot of assumptions that made it hard to be implemented. So then I went back to Berkeley for 1985, and I had to do my qualifying exam. So qualifying exam is something that is a university exam. It's an oral exam that every PhD student has to take, and it's usually a long exam. It takes 2, 3 or 4 hours to do, and that exam has 2 parts, at least in the operations research department. For the first part is the chair of the exam gives you a paper 1 month before the exam, and you have to read this paper and then do a presentation of this paper. And the paper I got was a paper written by Todd and Burrell, which was a paper on adapting Karmarkar's algorithm using dual variables. So they show how to extract dual variables from Karmarkar's algorithm. And then there I implemented, because I had done the implementation in the course, so I implemented that algorithm. And my talk was very, very nice. People who were there, the five examiners, really appreciated the talk. So they didn't give me a very hard time in the second part of the exam, which is the syllabus, where you give the areas you want to be examined in. And so the questions that they gave were all sort of softball questions. So there was not, and so I was doing these things in parallel. So this was very interesting. We're still very interested in interior point methods, but I was doing my thesis also. And so I did an internship in 1985 in Palo Alto at Fairchild Semiconductor, where I actually saw in real life what it was that my thesis was dealing with. So I actually went inside the fabs and saw what were the problems and how to deal with it. And we developed some simulators that simulated the fab, and then we tested our policies using the simulators. That was the thesis, basically. And at the same time, so this was sort of in the middle of 1985. There was a special year at the Mathematical Sciences Research Institute in Berkeley on combinatorial optimization, which involved also linear programming. And so Karmarkar and Eva Tardish, for example, they were both there at this, for at least for the first 6 months. And Karmarkar gave a talk on his algorithm in Berkeley, and in this talk, it became apparent that he was looking for teams from universities to collaborate with him, because he had been making all these claims, and basically AT&T was not letting him describe the details of his implementation at AT&T. And he wanted to collaborate with them, because then they told him that he could collaborate with a university team, and then would be able to describe the details. So Adler again went and volunteered. We'll be this group, and basically in the fall of 1985, Adler was going to teach large-scale systems, which is like a decomposition course. And instead of doing that, he got the class together and with Karmarkar there, and we decided to develop an implementation of his algorithm. And so, each student or groups of students got different parts, and fortunately, Geraldo Veiga, who was a Brazilian student back then at that time, and I got sort of the most central part of the algorithm, which was how to factor the linear system, which is the whole trick of
Yeah.
making the algorithm efficient.
Uh-huh.
And so we all worked on this, and we finally the semester ended, and we had something, but it wasn't completely ready yet for prime time. So I went on vacation to Brazil. When I came back in January of 1986, we continued working, and around February, I don't remember exactly the exact date, but around February, we were able to show that this algorithm could actually solve linear programs faster than a simplex method. This was the simplex method implemented in Minus software for nonlinear programming. And what we showed is that as the size of the problem grew, the difference grew. So and the break-even point was at around 1,000 constraints. And so we worked on this. It was very exciting. This was perhaps the most exciting thing I worked on in my whole life. And because linear programming was a big thing, Karmarkar was getting all this attention in the New York Times and this and that, and and then so there was a conference coming up, the TIMS ORSA. This was before Informs. It was called TIMS ORSA in the spring and ORSA TIMS in the fall. And this is TIMS ORSA in Los Angeles in April of 1986. So and at that conference, we submitted an abstract to present these results, and Elon Adler presented the results, and the everything was completely packed. And from there on, between 1986 to like 1988, 89, 90, anytime we gave a talk on this stuff, the room would just be completely packed. People wouldn't be able to fit in the front door. And so that was quite an exciting time. And yeah, and and right after that, then we started collaborating with the AT&T team for about a year, and then I graduated. So finally, when I graduated, I had to look for a place to work. But right before I graduated, Karmarkar asked me for my CV, and if I wasn't interested in joining AT&T, and I said sure, and, and I gave him the CV, and then they were able to make an offer for me to join AT&T. But I told them that I couldn't move to New Jersey immediately because Lucia was still working on her PhD, and she would be finishing a year later because she started a year early, and we had a baby in the middle, so that things more complicated. And so she decided to. So they decided to accept, and what they did is that they set up a computer running Unix in my house in my apartment in New Jersey, in California, in Berkeley, and so I worked for a year there, and the arrangement we had is that every month I would go to New Jersey for a week, and so that's how I started flying a lot.
You're used to work from home since that time, right?
Yeah, since that time, yeah. So we were pioneers.
Yeah. In which language did you code the algorithm?
Yeah, so this algorithm for linear programming, we did it in Fortran. Yeah, so that was
and
I guess for some matrix operations, Fortran was at that time at least considered the best language. And Karmarkar was a very good programmer, even though he didn't touch the code when we implemented. He was just overlooking us, but he would have very good memory, so he could remember all the loops and where the loops were in the code and everything. So he helped a lot with the debugging.
Yes, I was going to ask exactly that. How was the experience of working with him?
Yeah, it was fantastic. He's a lot of people have a hard time getting along with him, but I didn't, and he's I think the smartest person I ever met. He's very fast, very quick, and had lots of great ideas, and so it was a really great experience. So when he decided to try to hire me there, I was very happy. And so during that year that I was working from New Jersey, from Berkeley, I started collaborating with Tom Feo.
Mm-hmm.
Tom was a former colleague of mine at Berkeley. He did his PhD there. We were office mates, and he was then a professor at University of Texas, and he invited me to go to visit and give some talks, and then that's where I met Fred Glover, who was spending a sabbatical there, and then we got interested in heuristics, and we wrote this paper on a probabilistic heuristic for set covering. So the set covering, the greedy algorithm for set covering is one that's proposed and analyzed by David Johnson.
Mm-hmm.
And but it's a greedy algorithm. So how could you improve that greedy algorithm? Use some randomization and use some local search. So that's how that came out. And we didn't call it GRASP at that time because it was we called it a probabilistic heuristic for difficult set covering problems. Mm-hmm. But then we saw that you could actually use the same idea for solving other problems. So I started working immediately on some maximum independent set problem. With Tom joined me, and Tom was working on some other problems. And eventually, we decided to write a paper where we would describe this as a meta-heuristic, a general purpose framework for solving problems. And we wrote this paper. Before writing the paper, we decided to do a tutorial. So we did a tutorial at an Arsta Tim's meeting. This was in April of 1991. And it was very successful. A lot of people were interested. There were a lot of questions. So we said, maybe we should write a paper on this tutorial. And this is the paper that finally came out in Journal of Global Optimization in 1995. You see, from 1991 to 95, there were 4 years. And what happened is that we wrote the paper, we submitted it to several journals, and it was rejected. It got rejected from OR, it got rejected Management Science, and then finally we sent it to JOGO, and it got accepted in JOGO. And nowadays it's like the second or third most cited paper in JOGO, in the history of JOGO. Yeah. So and when we wrote this tutorial, we finally called it GRASP, and there's a curious story about how the name GRASP came up, and so as I said before, we called it a probabilistic algorithm, right? But Tom Feo says he was driving in Austin when he saw an outdoor, like an ad about a rock and roll group, and the name of the rock and roll group had the word GRASP in it. I don't know if it's just GRASP or from the GRASP or something like that. And then he immediately saw GRASP, greedy randomized adaptive search procedure, and that's how the name came up.
That's awesome.
So yeah, so that was that story.
Yeah.
What happened to him? And at that time, I didn't give much importance to GRASP itself, because since I was working in this other area, which was, I felt it was much more important, linear programming and this and that, and so I would give very few talks, and I would sort of downplay because it's such a simple algorithm. Over time, though, it's actually had more impact at least in my literature production is the GRASP stuff.
Yeah, most people know you for the GRASP, but the implementation of a Karmarkar's algorithm appeared in MathProg, right?
Yes, yes,
I think
yes.
late 80s. So
Yeah,
you're on fire there, right? In the during the late 80s, right? You had the
yeah. It was,
implementation and you had also the grasp
yeah.
idea. And
It's the kind of thing of being in the right place at the right time. Right? This is the
yeah.
that helped a lot, and we had really smart colleagues, and everyone was very excited to work, and we worked nights and weekends and everything, and
Mhm.
so so I worked in this scheme of working from home for a year, and then finally moved to New Jersey. Uh, my wife got a job at Bell Labs also, not in the research division, but in sort of advanced development, applied research, and I I started working. So at that time that I had been in at University of Texas, they actually wanted me to apply for a position there. So I actually interviewed in University of Texas, and I was made an offer. So I had this University of Texas offer with me that I could use to negotiate with AT&T, because I wanted to work in the research division and not where I was working, which was in the team that was developing the algorithm to market the algorithm.
Mm.
And and what I would usually do when I went to New Jersey is I'd work in the morning at this group and in the afternoon with Karmarkar and Ramakrishnan in the research division, and that's where I wanted to work. So I told them, okay, if I can, for me to come to AT&T full time, I'll want to go to the research division and not to this other ADSS division, and and basically they said yes, and they made me an offer, and then and it was very difficult to say no to University of Texas. So they were so nice, and they had such a good offer, and but eventually that's what happened. I said that I'll go to AT&T Bell Labs, and then we moved in 1988 in September. We moved to New Jersey.
Yeah. And what happened to Tom Fair, by the way?
Yeah, so Tom Fair, he was a professor at University of Texas until he got tenure. And when he got tenure, he started working just half time there. And he had a company which was called Optimization Alternatives, which basically did the transportation applications, like a railroad and things of that sort. And he said to me that he really liked it. And I visited him a few times and stayed in his house, and I would see him on the phone interacting with customers. And I said, this guy is really good at, at this. He could spend 3 hours on the phone with a customer trying to sell a system to them. So eventually he went full time to Optimization Alternatives. This is a company he started with his wife, and who was also a student at Berkeley. She was a master's student there. And then they worked. Her name was Debbie Feo. And so he basically stayed full time at this company, and for many years, maybe 20 years. I don't know exactly how many years, but it was a long time. And he eventually sold the company. And now he started a new company maybe 10 years ago, and this company does health care applications. So he's in business, and so he still lives in Austin, Texas.
Great.
And he's doing very well.
So now moving to AT&T, you had a lot of time to do research, and I think that was really what you wanted to do in the end, right?
Yeah.
So what were your main contributions during all those years you spent working there?
Yeah, so as I said, there is the research division, and AT&T research division at the time when I joined was it was like paradise if you wanted to do science. They had 8 people had gotten already Nobel Prizes working there, and we had it was really big. It was 1,600 scientists and in one location, or maybe a couple of locations, but 1,600. Half of those scientists were physicists. So those were the guys who got the Nobel Prizes, all the physicists. And then the other half were either mathematicians, electrical engineers, or computer scientists, statisticians. And so we had tremendous research groups. So I was working in the Mathematical Sciences Research Center, which was headed by Mike Gary. And this is the Gary and Johnson book. Gary was the director, and David Johnson was the head of our department. So we had those two guys. They had been working together. They wrote this very influential book on NP completeness, and the department also was very strong. So there were, Karmarkar was working there, David Johnson, Peter Shor, who later on went to invent the first algorithm for quantum computing that had some lot of influence, right? And
you had good company then.
Yeah, it was Ed Hoffman, and then Applegate joined there also. So
wow.
we had
an army.
We had a really good team, and so it was very easy to. Everyone had their doors they had this policy of open doors, so you could just walk into someone's office and go to the blackboard, and if you had an idea or a question, you could discuss. So it was very productive, very fruitful. And so in the beginning, I wanted to sort of become more independent from Karmarkar. And so I started working a lot on trying to extend the interior point methods to network flows. So I did a lot of that work with Geraldo Veiga. And then after that, we were joined with some people in Portugal. So there's Luis Portugal and Joaquim Jutsi and João Patrício. And also collaborated in one paper with a guy from Japan, Takashi Tsuchiya. And so we worked a few years on that, published a few papers, and at the same time I was seeing that GRASP was getting traction, and David Johnson had told me something that was really important for me when I joined AT&T, is that he said that in the first 10 years of your career, you should try to maximize the number of conferences you go to so that people will know you. And I did just that. I went to a lot of conferences, went to a lot of university visits. We also had a very interesting program there where we could hire professors to serve as consultants, basically to collaborate with us at AT&T. And I had several of those. Panos Pardalos was one, Celso Ribeiro was another, Abílio Lucena was another. And they would come and spend like 10 days a year, and they could break it into 3 visits or 2 visits. Like Panos came several times because it was closer, but the other guys would come once a year. And so that was really good to get your research moving along. And basically, I started attracting people to come work with me, and then we had this whole line of research on GRASP. So we had hybridizations of GRASP and use of path relinking, which is something that Fred Glover contributed, and so that was another area that I had a major contribution. And then the other thing that I got interested in was this random key genetic algorithm that at the time that I heard about it, José Gonçalves had been starting to play around with this algorithm, and I was actually editor of a paper that he submitted to Journal of Heuristics. And so I followed the paper and I saw, maybe this thing could be more general than just for the specific problem that he was solving, which was a scheduling problem. And then I started collaborating with José. This is around, actually before I started collaborating with him, we had a student from Sweden who came to University of Florida to work with Panos on his master's thesis. And I sort of co-advised him. and we published a paper on this. We call it a hybrid genetic algorithm, but it was a we hadn't given the name biased random key yet to it, but for OSPF weight setting problems. So it's a traffic engineering problem, and so we published that paper, and then Luciana Burial was my second PhD student who came from Brazil to work with me. Brazilian National Science Foundation had a very interesting program where they would send their PhD students abroad for a year or so, and they could work on their thesis. And so I've had over the years several of them. The first was Renata Yex, who came from Catholic University. She was a student of Celso Ribeiro, and so I co-advised her, and we developed. We studied the distribution, runtime distribution of GRASP, and also as a byproduct, we produced the TTT plots, time to target plots, which have then been used a lot by lots of researchers.
Yeah, very famous. Yeah,
compare performance.
I myself had used that.
Yeah, that's good. And then with Luciana, we basically built upon the work that we had started with this master's student at Florida. And so we added local search to the decoder, to make it more effective. And so Luciana worked on the same problem, but improved the results. And then she also, as a byproduct, she worked on dynamic shortest path problems. Because this is in the local search that we had to change the weights and then compute shortest paths. So we wanted to do that fast. So that was part. And then we also applied this for network design. So she stayed there 15 months and had a very productive. Not only did she work with me, but she worked with a bunch of other papers. She has papers with David Johnson and Peter Shore and David Applegate and Mikkel Tarup, and so that was very good to have her there working with us. And then that more or less at that time is that I went to a conference. See, lots of these people I met in conferences. So Renata I met at a summer school. Same with Luciana at a summer school, and then as I started working on these problems with people that I met in different locations, I got more involved. And then I hadn't seen. So José Gonçalves is someone who went to Berkeley with me also, just like Tom Feo did, and I hadn't seen him in a long time. So he graduated in 1987, and I did too, and I hadn't seen him in years. And then I met him once in 1998 in Portugal, but we just saw each other for a very short period. And then in 2000 we went to a conference, and so this is at this conference that's when he showed me this algorithm that eventually we started collaborating on, and then we've been collaborating on this stuff since then. So we have I don't know, tons of papers on this topic, and we have one paper that describes it as a meta heuristic, and that's where we give the name biased random key genetic algorithm. And then eventually I recruited José to come work at Amazon, so he currently works at Amazon.
Right. I have to ask you this: how was the experience of working with David Johnson?
David Johnson is a fantastic leader. Lots of ideas, knows everything. He's very, very careful about everything he does. He does everything with a lot of intensity. And if you write a paper with him, he'll go over it, over and over and over and over. And I have to say that David's last paper in his life, he passed away in 2016, was a paper we wrote, and we had been working on this paper for about 8 years. And so I remember when he told me that he was sick, he said, I'm gonna give you all the files for safekeeping, just in case something happens to me, so that you can finish the paper. And that's exactly what happened. So we had to go to his file system and get the files and then put things together. And we had some experiments, and I had to run some other stuff. He had the programs there, and so he was not only so he was my manager at AT&T for 25 years. So he was like a mentor to me. Also, he guided me along my career, and so it was great to have known him and have worked with him.
Great. So in the end, this last paper is like paying tribute to him, right?
Yes. Yeah. We had 9 authors, I think, because this was done with a lot of people at AT&T, and some people who were there as postdocs and as some summer students, as interns. But we eventually decided to put his name as the leading author, and then we dedicate the paper to him. And we published this paper in Operations Research.
Wow.
Which is a very good journal in that field. Right?
Yeah, quite a homage. That's very nice.
Yes.
At some point, you developed a continuous grasp, right?
That's right. Yeah. So we had grasp, the general idea of grasp, which was designed for solving combinatorial optimization or discrete optimization problems. And there was a student, also a Brazilian student, Claudio Menezes of Panos Pardalas in Florida, who I used to go a lot to Florida to work with the guys down there. And in one of these trips, Panos was traveling, so I got to work a lot with this guy. And he had this idea: is why don't we extend this algorithm to solving continuous optimization problems? And so we sat down for about a weekend or so, and then we jotted some ideas. And then he had another colleague there, by last name of Hirsch, and they started working together, and they built this thing into an idea. And then we published several papers applying continuous grasp. So basically, it's you want to solve a problem. You have f of x, where f can be any function with discontinuities and non-differentiable, and you want to find that subject to box constraints. And so that's the basic idea of the problem that we solve. And then we applied just the general notion of grasp, where you construct a solution, and this construction of the solution is basically the result of several line searches in the different dimensions. And we build a solution, and then from there we do local search, which is just basically exploring the neighborhood of that current solution.
Yeah, I had a student that coded that for his master's, Eduardo Queiroga. Yes. We did continuous graphs for a clustering problem. It was something about 2007. I'm not sure. When was that?
Yeah, around there. Yeah, maybe around there. It becomes a little blurry for me, but I know it was before 2013.
Okay.
Because that was 2013 was the last time I visited.
Okay.
I visited Florida.
Yeah, I remember in 2007 when I attended our Brazilian OR conference for the first time as PPO. It was the first time, of course, I was presenting something, and it was a grasp. And it turned out that you were there at the session, and it was actually packed. And for me, it was a bit surreal, right? This young guy comes and is going to present the work, and you have the guy who proposed the method there. And I even made a joke. I don't know if you remember that, probably not, but they said I'm even embarrassed to present about grasp. And they laughed, and I was a bit relaxed from that point onwards. And at the end of my presentation, you made a question, and you asked, and you suggested actually to combine grasp with path relinking at that time. And after that, we had a chat with Luciana and Satoru, and you told about the possibility of going to AT&T. You were very kind, and that had a very impact on me personally. You were kind of a celebrity. In my opinion, you were like can be considered a national hero among our community. So I see this guy, very famous, and he's just there relaxed and talking to me as though he knew me for a while. And that was very inspiring, I must say. And to this day I remember very, dearly, and it was a great moment, and that inspired me for the rest of my career. I see that even though you left Brazil a long time ago, you still keep this strong connection. I see that your mom actually is very active online.
Yeah, yes.
And you kept on collaborating with people here. You were responsible for helping Luciana quite a lot, as you mentioned, and other Brazilian guys. So what motivates you to keep on helping people here and to have all these connections after all these years?
Yeah, one thing is that I'm Brazilian, so I feel very comfortable when I'm working with Brazilians. So there's a cultural component. The other thing is that since I know a lot of people in Brazil, I can get very good recommendations from professors about their students. Because often, if you don't know the student very well, it's sort of a gamble, right, when you get a student.
Yeah.
So usually, professors would ask to send their students to me, and they'd say, "Ah, this guy is very good. This woman is very good," and so that helped a lot. And I know that in our field, Brazil is very strong. There's a big community and produces a lot. I'm very impressed with the younger people who are coming out of the programs now in Brazil, and so that inspires me to have them recruit them to where I work now. So when I joined Amazon, we didn't have many Brazilians. Actually, when I joined, we didn't have any Brazilians. A month later, Renato Werneck joined.
Wow.
Was
Yeah.
That, by the way, had been my intern at AT&T for two summers, and so I knew him very well. He had been working at Microsoft.
I know.
But since then, we've grown just in our small team, which is in Amazon, is the middle mile planning, research, and optimization sciences team. We have, I think, 6 Brazilians now.
Wow.
Yeah. So and basically they've been recruited through either connections or people who I know. I also had a Brazilian PhD student at University of Washington. I'm an affiliated professor there at University of Washington, so I can advise students there. And so someone I knew who was a former student of Panos Pardalos was a professor there, and he said that he had accepted a Brazilian student and asked me if I wanted to co-advise her, and so I did. And so she's one of the Brazilians who joined our team now at Amazon.
Great.
Yeah, but I feel very honored to have these people working there and seeing the whole community of operations research grow. Every time I go to a Brazilian OR conference, I'm very, very impressed at the number of people and the work that everyone is doing.
Yeah, and you certainly is a great influence on all of us. So I think you should be aware of that. And can you tell me about the transition from AT&T to Amazon?
Yes, I can tell you. First of all, when I joined AT&T, it was as I said, it was like a paradise, right, for research scientists. So you could basically do whatever you wanted, and there's lots of really smart people working there, and over time, what happened is that this is something that didn't happen only in AT&T, but everywhere. There was more emphasis to more immediate results, and so they wanted to do some projects that had sort of immediate, and not before. It was sort of you could work for things that are in the long range. Let's do something in linear programming, and that might not be immediate. But then back in 2002, there was a big cut at AT&T, where in the research division, this is after so in 1996 we had a split of AT&T into 3 companies, and basically 2 companies, AT&T and Lucent Technologies, they split the research division, and so AT&T ended up with about half of the researchers, and they ended up at the end in 2002 they had about 600 researchers, and then in one day, remember that in 2001 there was this internet bubble, right? That the telecom companies got affected, so they had to make cuts, and in one day they got rid of 2/3 of the researchers in the labs, and so that everyone who had been working there and thought that this was sort of like a tenured position learned the hard way that it was not really a tenured position, and your job was not secure, and so there was not only did these 400 people leave, and then we were down to 200 people, which is still a good sized group, but a lot of people, because of this uncertainty, started leaving the research and going, and they all went to very good places like MIT and so on. And so then the company started growing again. The research started growing, and it grew to maybe around 400 people. But then there was a second wave and a third wave of shrinking. Basically, I think AT&T wanted to get to a size that it could then be sold, and this is what happened. It got sold to SBC, which changed its name to AT&T, and SBC was a more conservative company. It was a local telephone company. But and so they had these second and third waves, and each time they had a wave, they would fire a bunch of really top people, people in the National Academy of Science, and people who won all these prizes and things. And then the third wave that they had, they decided to dismantle David Johnson's department where I worked. And, I don't know if they believe that we're doing just too much theoretical work, or which we did a lot of practical work also, that was important for the company. But for some reason, they decided to get rid of the department. So they split the department. They made David go do something on his own, and then the 10 people who worked, 3 went to one group, 2 went to another, and then they split it. And I ended up in a different department called the Network Evolution Research Department, and so I had to change cities, and what really made a difference is that 6 months after this dismantling, they actually forced David to retire. Basically, they laid him off, and this was a person who had been working at the company for 40 years. And so he was really dedicated. Even when he was on vacation, he would go have lunch with us at AT&T. So he's a guy who really liked the job, and really so he really felt it when he got laid off.
Yeah, I can imagine.
And basically within a year, everyone except for 2 people had already left the group. Someone to Google, someone to Yahoo Research, and so on. And then I was there. It was myself and David Applegate were the 2 ones that were left. And then I said, okay, I'm not going to be the last one. So I started looking for a place to go, and one place that someone before who was in the team, a couple of people in the team had interviewed at Amazon, and they had said good things about what they saw there. So I got interested in that, and that was the only place. So I applied. And it was the only place that I applied to when I was looking for a position, and I really liked what I saw there, and they made me an offer. The only thing that I told them is that I got an offer. I interviewed in April, and I got an offer in May. This is of 2014, and I told them that I couldn't leave immediately because I had to stay at AT&T until the end of the year. Until the end of November, because I had a PhD student. So it was my last PhD student at AT&T, Fernando Stefanello, who was co-advised by Luciana. So he was there until the end of November. So I stayed there with him, and we finished his research. And so on the 30th of November, I retired from AT&T. Basically, I had enough years of AT&T, and if you had your years with your age, you can retire, and then you can get a pension. And so I retired, and then 1 week later, I joined Amazon.
You told me you actually applied for a lower position there by mistake.
Yeah, so they said that they had something called senior operations research scientist, and I thought, no, senior, that's me. But in fact, senior is like 2 grades lower than the grade that I was in, or something like that. But that I was in at AT&T. But I didn't know the titles at AT&T and at Amazon were slightly different, and so yeah, and so someone there figured out when they were interviewing me, oh, it's this guy, and then I'm sure this is he applied to the wrong position, and then they got the right recruiters involved and everything, and then I ended up going to work for Russell Algor, who was he's the chief scientist at Amazon, and he heads a team called modeling and optimization. It's a very strong team. They do a lot of work, responsible for a lot of things that happen at Amazon, and I worked there for 3 years, and then one of the teams inside of his team got spun off, and I was spun off, and that it was a team that did middle mile research, and so now I work in this middle mile research.
So
which is headed by Tim Jacobs. That's a different guy.
So you were, before the pandemic, you were commuting from New Jersey and Seattle back and forth?
Yeah, so before the pandemic, I was living in Seattle, and I actually live quite close to the office, which was a big difference from when I worked at AT&T. AT&T, I had to commute an hour by car to get to the office, and there I was only 3 kilometers away from the office, so it was like a 5 to 10 minute car ride. Or you could even walk or take the bus. So I would go most days, go to the office. Even though, before, when I was at AT&T, it was sort of a hybrid. I would work many days from home, and then some days I'd go to the office. But in Amazon, I'd go most days to the office, and this until we had the pandemic. And then the pandemic, they closed down Amazon. The Amazon offices, when there was a report of someone who got infected, and that was in, I think, March of 2020. And then since then, everyone has been working from home.
I see.
And I decided to come work in New Jersey, where I used to live, and my wife still lives, and so we have been here for a year now.
Okay. I had some students asking me to ask you to tell what is it like a regular day at Amazon, of course before the pandemic. So if you still code, and what language you code, and all that.
I code very little. Definitely not as much as I used to, but I've done a little bit of coding, but mainly if I have to code something, I'll usually get someone who codes better than I do, and then just tell them exactly what I want to be coded, and then they'll go and code it. One thing that in Amazon is quite interesting, that I didn't experience very much at AT&T, is that there's a lot of mentoring that goes on at Amazon. So I've been mentoring a lot of junior scientists there. So we'll schedule with some of them every 2 weeks a half an hour, or every month a half an hour. And so this is something that I've done and I've enjoyed a lot. The other thing that I've enjoyed doing there is organizing conferences that we have. So we have a lot of conferences that are internal conferences, and also we have conferences where we invite faculty to come and spend a few days with us. So I've done a lot of that. And besides that, we have a lot of meetings. So that's something that I didn't have very much at AT&T, meetings. Uh, but in Amazon, we have a lot. And if you're not careful, you spend your whole day in meetings. So you have the other thing that we do a lot in Amazon. I think it's reflects the fact that Amazon is growing so much, is that we do a lot of interviewing. At AT&T, maybe I interviewed over the 27 years that I was there. Maybe if I interviewed 10 people, maybe that was too much. But at Amazon, I've interviewed hundreds of people.
Wow.
So in the 6 years that I've been there, so it's they have a very interesting process for interviewing. It's very organized, and it's something that they organize so it can be done at scale, so that you have people coming in and interviewing all the time. So that's another thing that I found interesting. Interviews at AT&T were basically just chatting about the person's research. At Amazon, it's more structured. You have to try to examine the person from different aspects, and so that was something interesting that I learned, and actually now I enjoy it because I learn a lot from the interviews, because you interview someone, but they'll teach you a lot of stuff. So
Right.
that's something I enjoy.
I wonder, Mauricio, when you left AT&T, did you think about trying to apply for a position at some university?
Yeah. So when I said that the only place I looked for a position was Amazon, it was not entirely true, because there was a position that opened up at University of Florida to be department head, and Ponos convinced me to go there and interview there. But then when I saw what that entails, basically being a department head in some university like this involves a lot of fundraising, and you don't even have to teach, and they say you can do research if you want. So it's basically like a full-time thing that you have a coat and tie, and then you're trying to get money for the department. So it didn't. When I learned about it, I didn't like it very much, and I think it came across because at the end I wasn't offered this position. But who knows in the future, right? In the future, I may want to do something like what Nelson Maculan did, where he'll spend 3 months here, 4 months there, and as visiting professor. So that could be something that could fit in my future, I think.
Yeah, you like traveling quite a lot, right? So
yeah, so it'd be nice if I wouldn't want to go to a place where I would stay a very long time, several years, but maybe a year.
So
but that's for the future. I still don't have any definite plans to leave Amazon right now.
So this brings me to maybe the last question. You have achieved many things in your life. You have a very, very long career. But is there something that you still wish to accomplish?
So this interaction in a university is something that I've had some interaction, because I've collaborated a lot with people in university, and I've been an affiliate professor both at University of Florida and University of Washington. But perhaps being able to spend some time and seeing exactly how university works from a professor point of view is something I haven't done, and I might like to do. Also, the other things that I have a lot of plans for books that I want to write, and I know that writing a book is something that takes a long time. Usually when I write books or even edit books, it takes like 5-6 years. And so if I want to do another book, that's something that I would probably do after I get into my next phase of my career. Yeah, I enjoy writing books, but it's something that's like it's a craft, right? It takes you have to you have to take your time and make it a nice have a nice result at the end.
Definitely. Yeah, Mauricio, I could stay here for hours, but I don't want to take much of your time. Uh, I'm I'm very happy that you accepted this invitation, and I cannot find even the words to thank you. It was a wonderful experience, and to hear all these stories, I'm sure many people will also be very very interested about that. And I mean, uh, I hope you also had a good time, right?
Yes, I did. uh, yeah, it's you're a very good interviewer, and you were able to guide our discussion into the right direction and
Yeah.
get concluding remarks. So that was very good.
Yeah, just I know you're being very kind as usual. But anyway, I know you got the vaccines. I mean, the 2 doses, and
Yes.
I hope you're safe there, along with your wife. And I just hope everything uh, goes back to normal, maybe by the end of the year or even next year. Um, and of course, I wish you all the best. Maybe we can meet someday in a conference or when you're visiting Brazil. I'm sure you probably miss Brazil, right? Because you
Yes,
cannot visit
very
here.
much. I think I haven't been away for such a long period in a long time. So I was in Brazil. I left Brazil in January of 2020. So it's been a year and 3 months. Usually I go 3, 4 times a year.
Yeah, quite a lot.
So,
Yeah. So see you soon, and ciao. Bye, Mauricio.
yeah. Okay. Obrigado.
Ah, de nada. You're welcome. Ciao.
Bye.